In this video, we'll take up the challenge trigonometry problems. So the first question, we just have to make sure we draw the diagram correctly. So she first leaves on a bearing of 52 degrees, and then from the camp, she travels on a bearing of 159 degrees. So using the fact that these angles are alternate angles, then the interior angle at C is 73 degrees because it's 52 plus 21. So once you have that, then you can solve for side angle. You're given side angle sides. You can solve for third side using cosine law. Once you have all three sides, you can calculate the total distance to return back to where she was to begin with. Okay. So here, you're flying at an altitude of 1.5 kilometers, angle of depression 40, angle of depression of 60. So that means this angle here is 20 degrees. Once again, you can use alternate angles to help you out. And this is a right triangle, of course. So basically, you have a beautiful rectangle here. And then you can solve for what I've labeled as y and what I've labeled as x. And I know, so solve for z and y. And then what you really want is x, because x will represent the width of the oil spill. And x is, quite simply, z minus y. For question 3, we have basically, it's like what we did last time, or last chapter, with the angle of elevation, angle of depression, but instead we're given the whole angle here. Okay, from the top to the bottom is 36 degrees. So you have the distance from Tom to the building is 14 meters. So you can create your two right triangles, but be very careful. You don't know how we are splitting the angle of 36 degrees. Please don't assume that it's 18 and 18, because that is not the case. So anyways, make your two right triangles. So these are the two unknown angles. You can solve for theta. Now once you have theta, then you can solve for beta, because you know that the two angles sum up to 36 degrees. And then once you have beta, you can solve for x, and x plus 1.5 will give you the height of the building. Question 4, I would argue, is pretty similar to the first question we did. Just have to be very careful with the diagram. Use the alternate angles as your aid. So this diagram is very, very similar to the first question. So once again, side angle side, so use the cosine law, and then you can solve for the angle using the sine law. All right, number 5, our classic clock problem. This is very similar to the problem that we did in our handout. So find the angle of rotation of the minute hand and the rotation of the hour hand. And then the difference is the interior angle of the triangle that's created by the two hands. And then you once you have that interior angle, you can solve for the distance between the tips of the two hands using the cosine law. Okay, question 6. So question 6 basically solved for the angle at the peak of the roof. We know the slope, so if this has a slope of 1/2, if this is what I've labeled as x, then this must be 2x, because you want a ratio of 1 to 2 for the rise to the run. And on the other side, you want x to 3x, because you want a slope of 1/3. You can solve for the two interior angles, which I've labeled as theta and beta. Just do inverse tan of half, inverse tan of 1/3, and then I can solve for the angle at the peak of the roof, because all three angles sum up to 180. For the last question, this one's very nice. You go down south, and then you return back to the original location. Oh, sorry, you want to catch the aircraft carrier. So the total distance, if this is x, this must be 2,000 minus x, because you only have enough fuel for 2,000 kilometers. And then use the cosine law. Just be careful with your expansion, and then you can solve for x. Okay, yeah, 5 hours of flying is 2,000 kilometers. Okay, so that's the solution for the challenge trigonometry problems.